we will discuss communication subsystems. The communication subsystem is a major component of communication satellite, and the remainder of the satellite is there solely to support it. So it is a part of payload, right? It is a part of payload. Frequently, the communication equipments uh, is only a small part of the weight and volume of the whole satellite. We have already discussed lots of subsystems related to the satellite, and all those subsystems are used to maintain or to control the satellite in its own position, right? They are actually not offering the actual service. For communication satellite, the communication is the service, but other subsystems like TTC and AM, like other subsystems, power subsystems, they are not actually providing the communication operation, right? Communication operation, different subsystem is there, and that particular subsystem is used only for communication, not to monitor, not to provide any monitoring sensors or monitoring data to the TTC and M subsystem. It is not like that. It is a payload. Communication subsystem is a payload, and to maintain that particular payload, all the other subsystems used to work. Get it? So it is usually composed of one or more antennas which receives and transmit over wide bandwidths at microwave frequencies, and a set of receivers and transmitters that amplify and retransmit the incoming signal. The receiver transmitter unit is called the transponders. So one of the major component of this communication subsystem is the transponder. There are two types of transponder in use on satellites: the linear or bent pipe transponder that amplifies the receiver signal and retransmits it at the different, usually lower frequencies, and the baseband processing transponder, which is used only with digital signals, that converts the received signal to baseband, then process it, and then retransmits the digital signal. So we have previously the analog system was used. Nowadays, this type of system, which composed of digital system, they are used in uh, recent days. The satellite transponders have limited output power, and the earth stations are at least 36,000 kilometers away from geosatellite. Actually, the ground station distance is more than 36,000 kilometers, because 36,000 kilometers is the distance of the subsatellite point, right? And not necessarily every time the subsatellite point will be the only ground station. Ground station may be more than one ground station may usually used to increase the reliability, right? So the ground station distance is actually more than 36,000, maybe 37,000 or 38,000 kilometers away from the satellite. So receive power level, even with the large aperture earth station antennas. See, earth station antenna may be huge, maybe 5-meter antenna, maybe more than 5-meter antenna may be used because it is in the ground station, right? But even with this such large aperture antenna, very small and uh, very small amount of power is received, of the order of 10 to the power minus 10 watt. That means most of the time power is of the order of few picowatt, right? For the system to perform satisfactorily, the signal power must exceed the power of the noise generated in the receiver by between 5 to 25 dB, depending on the bandwidth of the transmitted signal and the modulation scheme used. Actually, modulation scheme plays a very important role in satellite communication system. Modulation controls the signal to noise ratio, right? So depending on the necessity, depending on the bandwidth, depending on the reliability, depending on various factors, modulation scheme is chosen. With low power transmitters, narrow receiver bandwidths have to be used to maintain the required signal to noise ratios. Recent satellites have transponders with greatly increased output powers, maybe of the order of 200 watts for direct broadcasting system, television system, and have steadily improved in bandwidth utilization efficiency. The total channel capacity of a satellite that uses a 500 megahertz band, this is a standard bandwidth at 6 by 4 gigahertz, that means it is in the C band, can be increased only if the bandwidth can be increased or reused, right? So different kind of reuse techniques have been developed. Large geo satellites also use both 6 by 4 gigahertz and 14 by 11 gigahertz, that means C band and Ku band, to obtain more bandwidth. The bands currently used for the majority of the services are 6 by 4 gigahertz, that means C band, that was actually used in previous days satellite, older satellites, and 14 by 11, that is Ku band, that is actually used nowadays. Also, there is another band that is used, that is 30 to 20 gigahertz, that is K band and Ka band. Uh, that those are the latest kind of satellites, they are using this particular band. The 6 by 4 gigahertz band was expanded from 500 megahertz bandwidth in each direction to 1000 uh, megahertz bandwidth. So similar bandwidth is available at 14 by 11 gigahertz, and Ka band satellites will be launched in the first decade of uh, our century to exploit the wider bandwidths available in the 30 by 20 gigahertz bands. So satellite systems designed for Ku band, that is 14 by 11 gigahertz, and Ka band, that is 30 by 20 gigahertz, have narrower antenna beams and better control of coverage pattern than satellites used in C band, that is 6 by 4 gigahertz was the C band. So nowadays we have lots of advancement in technology, in antenna technology, so we can generate high power at higher frequency range. We can have very good quality antenna at higher frequency ranges, like we have a very good antenna in Ka band, right? And the size of those antennas are also reduced. So based on depending on all those issues, we can have high efficiency, a high performing satellite system uh, that is available right now. So day by day the situation is improving, and we are getting better systems as the time passes. Transponders are actually the heart of communication subsystem. Many domestic satellites operating in C band, 6 by 4 gigahertz band, carry 24 active transponders. Well, the carrier frequency of those transponders are spaced 40 megahertz apart to allow guard bands for the 36 megahertz filter cards. So this one will show you how the frequency is uh, divided into 24 active transponders. So this is the first transponder, this is the second, this is third, sorry, this is second, this is third, this is fourth, this is fifth. So in this way they have divided the whole frequency range to cover the entire range of frequencies, each with 36 megahertz of bandwidth. So this is the transmitter section, this is the receiver section. So with a total of 500 megahertz available in single polarization satellite can accommodate 12 transponders across the band. And this one is actually showing the transponder arrangements, right? So input filter is there, then we have receiver driver, and we have input multiplexer, then we have TWT, means it is a high power amplifier. So then we have output multiplexer and the output filter. After that we have, that will be given to the uh, antenna. So this is how the whole thing is uh, whole thing is situated. So these are for vertical polarization, this is for horizontal polarization.